This is the 2012 F equals MA exam, and this is problem number 9. So we're given that we have a uniform spherical planet, and it has a radius of r, and the acceleration due to gravity at its surface is small g. And we're asked to find the escape velocity, v escape, of a particle from the planet's surface. So first off, let's figure out what small g is. Well, we know that for an object of some mass m, the gravitational force acting upon it will be g, large M, where large M we say is the mass of our uniform spherical planet times small m, the mass of our object, over r squared, which is since it's on the surface of the Earth. And this is equal to mg. So when we cancel out the m's, we find that g is just equal to large G times large M over r squared. So now we want to find our escape velocity. Well, one thing to do is that we know that for an escape velocity, our particle will initially have some potential energy from gravity. It will have some kinetic energy, which we want to be our escape kinetic energy. And what happens is once it escapes, it's going to end up somewhere where it has zero total energy. So to write this, we have that our kinetic energy, namely 1/2 mv, where v, we'll call this v is our escape velocity, v squared, plus, so this is our kinetic energy, plus our potential energy, which is negative large G times large M over R, times small m, is going to be equal to 0, because we want this to be 0. Since we want it to neither be moving and we don't want it to have a potential gravitational energy, so then it will escape from this planet and it won't come back. So we have this expression, and now we want to solve for v squared. So we can divide by small m on both sides to get that 1/2 v squared minus g large M over r equals 0. And then we have v squared is equal to, we add gm over r on both sides, and we multiply by 2 on both sides to get this. Now, we don't know what gm over r is, but we do know what g is, namely that g is gm over r squared. So we could rewrite this to be 2 times g, which gives us 2 large G times m over r squared. So if we multiply by another r, then we find that g times r is g times m times r over r squared, and so we can cancel out one of the r's to get gm over r. So we have v squared is equal to 2gr, and since we're fighting for v, we take the square root of both sides to conclude that the escape velocity is just the square root of 2g times r.